Welcome to the Unit 5 lesson covering multiplying and factoring for Algebra 1. So we are really just going to multiply polynomials and learn how to factor polynomials, or at least a very simplified version of factoring for now. So starting with a warm-up, we need to simplify these expressions, and we're just adding and subtracting. So remember, when we are adding, we are looking for like terms. So that would be like 5x squared and 2x squared, which would give us 7x squared. Then we have 6x and negative 9x, which would give us negative 3x, and negative 7 plus 1, which gives us negative 6. Okay? We'll use a black box so you can tell. All right, so then with number 2, because we have this negative in the front, that's like a negative 1. So remember, you have to change all of your signs after that negative. So I keep the first one exactly as it is. And then negative 1 times 8w squared is negative 8w squared. Negative 1 times a positive w is negative w. And negative 1 times negative 6 is positive 6. So then once you do that, you can combine your like terms. So starting with 3w squared and negative 8w squared, remember to keep those signs with you. That would give us negative 5w squared. Then negative 5w and negative w will combine because they are the same letter to the same power. And so negative 5 minus 1 gives us negative 6w. And then last but not least, we would have the 2 plus the 6, which would give us a positive 8. Okay? For number 3, when we are multiplying, negative 8 times 2c would give us negative 16c. And negative 8 times negative 1 would be a positive 1. Okay. And then last but not least, number 4, we're going to do a couple things. First, we have to distribute. So 7 times 5 gives us 35, and 7 times 2h gives us 14h. Then negative 10, be sure you're watching your signs, times 4h would be negative 40h. And negative 10 times negative 3 gives you positive 30. So then, combining your like terms, we have 14 minus 40, which would give us a negative 26h. And then 35 plus 30 would give us a positive 65. Alrighty, so we want to find the greatest common factor. Now, a greatest common factor is a number that you can divide all of the other numbers by. So when we look at 9, 15, and 21, think about what multiplies to 9. You have 1 and 9 and 3 and 3. And so with 9, 15, and 21, our greatest common factor is going to be 3, because we can do 9 divided by 3, which is just 3, 15 divided by 3, which is 5, and 21 divided by 3, which is 7. So whenever we're doing a greatest common factor, it needs to be whole numbers left over after you divide it out. So then for number 6, we have 12, 20, and 28. Again, we are looking for a greatest common factor. So if you just say, oh, 2, 2's good, 2 goes into all of them, then you're actually technically not right, because if we were to divide by 2, I'm just going to write it, that would leave a 6, a 10, and a 14. And you notice that is still, we have another factor in there that we could take out. So instead of doing that, you are going to have, you can actually take out a 4 for all of these, because 12 divided by 4 is 3, 20 divided by 4 is 5, and 28 divided by 4 is 7. Okay, so then with 7, we have 14a, 21a, and 5ab. Looking at the numbers, 14, 21, and 5, 5 is prime, so I actually can't take any numbers out at all. However, we can take out, these all share an a, so my greatest common factor would just be a, because then you'll be left with 14, 21, and 5b afterwards. So we are going to multiply again. Yay! So starting with negative 2g times 3g squared, that would be negative 2 times 3, which is negative 6. And then g squared times g, remember we're just going to add, so that's going to be g cubed. Then negative 2g times positive 7g would give us a negative 14 because negative 2 times 7. And then g times g is g squared. And then last but not least, negative 2g times negative 5. Negative 5 times negative 2 gives us a positive 10. And then we just keep the g. And we have it in standard form, so we are good to go. Yay! Okay. So for the next one, we are going to distribute again, but it's all good. 3 times negative 4 would give us negative 12. And then d squared times d cubed, remember we are adding, would be d to the 5th. And then 3d squared times 6d squared. 3 times 6 is 18. And d squared times d squared would be d to the 4th because you are adding the exponents again. 3d squared times negative 8d would be negative 24 because 3 times negative 8. And d squared times d would give us d cubed. And last but not least, 3d squared times 1 would just be 3d squared. Okay? Boop. All right. Now, I will say, technically, to simplify these, you need to also take out a greatest common factor. And so I'm actually going to take this a step farther. Notice with these 12, 18, 24, 3, all of them I can take out a 3. But since this first term is a negative, we don't really like that, so we're going to take out a negative 3. And then with my variable, the lowest exponent is d squared, so that's all I can take from all of them. And by doing this, which I am getting a little ahead of what we're doing, but by doing this, negative 12 divided by 3d squared is going to be a positive 4d cubed. Then 6d squared, and actually, you know what? We don't have to do this part. I lied. Let's make our life simpler. All right, so for example 2, we are going to simplify each expression and then write the answer in standard form. So we're going to distribute y times y gives us y squared, and y times 2 gives us 2y. And then negative 3y times y gives us negative 3y squared, and negative 3y times 15 gives us a positive 15y. So then when we combine them, y squared minus 3y squared gives us a negative 2y squared. And 2y plus 15y gives us 17y. Okay. For the next one, a squared times a is going to give us a cubed, and a squared times negative 1 gives us negative a squared. Then negative a times a squared gives us negative a cubed, and negative a times negative 3 gives us negative 3a. Now with this, the a cubes end up canceling each other out because one's positive and one is negative. So we end up with negative a squared minus 3a. Okay. So, like I was saying, the greatest common factor divides evenly into each term of an expression. When we're factoring a polynomial, it reverses the multiplication process. When factoring a monomial from a polynomial, the first step to find the GCF is to look at the polynomial's terms. You want to look for a common variable and a common factor. Okay? And when we talk about looking for a common factor, that is, if I have 2, 4, and 6, I can divide all of them by 2. And then looking for common variables would be like x squared and 3x squared or something like that. So we want to find the GCF for part A. So with 2x squared plus 10x squared minus 6x, looking at the numbers, I can take out a 2 because all of them can be divided by 2 evenly. And then when looking at my variables, the lowest exponent I have is 1 because it's the 6x, which means the most I can take from all of them is just 1x. So then if I take out a 2x, 2 divided by 2 would just give us 1, but then x to the 4th divided by x, think about it, there's 4 x's here, but I took 1 away, so that just leaves x cubed. Then 10x squared divided by 2x, 10 divided by 2 is 5, and then x squared divided by x, I had 2 x's, I took 1 away, would just leave me 1x. And then negative 6x divided by 2x, negative 6 divided by 2 is negative 3, and x divided by x is 1. So it just stays as a negative 3. Okay. So then for part B, looking at the numbers, we have 15, negative 10, and 25. And so our greatest common factor is going to be a 5 because we can take it from all three numbers. And then looking at my variables, I have c to the 4th, c cubed, and c squared. So my lowest exponent for variables is a 2, so that's all I can take. So I have 5c squared. If I just go through and divide the numbers, 15 divided by 5 is 3, and then c to the 4th divided by c squared, I had 4 c's, I took away 2, so that would leave c squared. Then negative 10 divided by 5 would be negative 2, and then c cubed divided by c squared would just be c because you had 3 and then you took 2 away. And then last but not least, 25 divided by 5 is 5, and we already took all of the c squareds from there, so we just leave it as 5. Okay? So we are going to use the GCF to factor each polynomial. And when we get into more difficult factoring, you're going to want to always check for your GCF. So looking at 16n squared, negative 12n, and 24, we can take out, let's see, 16, we can take out a 4, and we can take a 4 from 12 and 24. So it looks like our greatest common factor is going to be 4. We can't take out a variable because we don't have one with 24. So then we are just dividing. 16 divided by 4 is 4, oops, not w, n squared. And then negative 12 divided by 4 would be negative 3n. And 24 divided by 4 would give us positive 6. Okay. For part B, we can take out a z because there is a z in common with these numbers. And then 9 and 15, the greatest common factor is going to be 3 because 9 is very limited in what can be divided. But 9 divided by 3 gives us 3, and then z squared divided by z would give us 1z because I had 2, and then I took 1 out. And then negative 15 divided by 3z, negative 15 divided by 3 would give me negative 5. And the z just kind of, it was taken away, so we don't have to write it again. All right, so then with the last example, we have 14, 21, and 7. Our greatest common factor is going to be a 7 because all the numbers can be evenly divided by 7. And then looking at my variables, we would have e squared because, again, you want the lowest exponents when you're trying to find a GCF. So by doing this, 14 divided by 7 is 2. E to the 5th divided by e squared would leave us e cubed. Plus 21 divided by 7 is 3. E to the 4th divided by e squared would give us e squared because we had 4, then we took 2 away. And then negative 7e squared divided by negative 7e squared would just be minus 1 because it's that thing divided by itself. Okay? So we have a rectangular frame. Has side lengths 5x and 7x plus 1. The rectangular opening for a picture has side lengths 3x and 5x. What is the area of the frame? Write your answer in factored form. How can drawing a diagram help you solve the problem? How can you express the area of the wooden part of the frame as a difference of the areas? So now that we've read it, we're going to read again and underline. So a rectangular frame, that's important that it's rectangular, has side lengths 5x and 7x plus 1. The rectangular opening for the picture has side lengths 3x and 5x. What is the area of the frame? So, and we're also going to write answer in factored form, and we're going to draw a picture. So if I were to draw a frame, okay, I know the side lengths are 5x and 7x plus 1. And then the other inside piece of it, boop, 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 is 5x and 3x. And the reason why I know the 5x is on the 7x plus 1 side is because my opening has to be smaller than the actual frame itself. So then, if we're looking for the area of this green, let's pretend it's a green frame just for fun. Boop, 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 boop. Okay, if we are just trying to find the area of the frame, we are going to find the area of the big rectangle and then find the area of the little rectangle by doing the difference of the areas. So, starting with the big one, it would be 5x times 7x plus 1. Okay, and so when we distribute, 5x times 7x would give us 35x squared, and 5x times 1 gives us 5x. Then our small rectangle, okay, would be 3x times 5x, which would give us 15x squared. So then if I'm trying to figure out the difference of their areas, I would actually subtract 15x squared, which would leave me 20x squared plus 5x. Now, because they wanted the answer in factored form, I can't leave it like this because I have a greatest common factor. In these numbers, I can take out a 5, and with the variables, I can take out an x, which would leave me with 4x plus 1. Okay? All right, so example 6, we want to describe and correct the error made in this multiplying. So 5t times negative 6t should be negative 30t squared. Oh, I think that might be it, because negative 5t times 7 would be a positive 35t. Oh man, they got all sorts of messed up. So technically this should be squared, and this one should be positive. Okay, so we want to explain how to find the GCF of a polynomial. In your own words, you can do it too, but I would say look for a number that can be evenly divided. Oops. With all terms. And then on top of that, look at your variables and use the lowest degree. And remember, degree is the same as exponent. Okay, so if you have any questions, feel free to ask either in the comments below or in person or what have you. If this video was helpful at all, give it a like and subscribe to the video or subscribe to the channel so that you can get more notifications whenever we post more videos. Hopefully this was helpful, and we will see you later.